Alright, in this video we're going to be going through some equilibrium problems on the in-class worksheet. So number 1 says, using Le Chatelier's principle, describe 3 ways the equilibrium could be disrupted to produce more product in the following reaction. So basically we're saying that this reaction is currently at equilibrium. That means that the rate of the forward reaction is the same as the rate of the reverse reaction. And that means the concentrations of all of these are remaining relatively constant. So we want to make more product. So what could we do to disrupt the equilibrium to produce more product? Okay. First thing we could do is to increase either of these reactants. So we could increase the concentration of HC2H3O2. We could just add more of this, and that will shift the equilibrium to the right. We could also increase the concentration of water, although practically speaking, there's going to be more water around than will make an impact. It will be in excess to begin with, most likely, so that will not really have much of an effect. But for the sake of illustrating the concept of equilibrium, let's say that we can add more water. We can increase the concentration of water, which will shift the equilibrium to the right. We could also decrease or remove the acetate ion, C2H3O2-, or we could remove H3O+. Okay, and you may think, well, how do we make more product by removing a product? Well, if there's already a decent amount of this product in the reaction vessel, what we can do is remove that, and that will force the reaction to sense a void on the product side. So it will work to fill that void. It will work to shift the equilibrium to the right and produce more of that product. This happens in industry all the time, where a desired product is needed and it is removed in order to take advantage of the fact that the reactants will be consumed to make more of that product. Okay, so these are the 4 possibilities of shifting the equilibrium to the right. Now, number 2 says, with the same reaction, describe 3 ways the equilibrium could be disrupted to produce more reactant. Basically, it's going to be the same as these 4, except the arrows are going to be reversed. So we could remove the reactant, H2C3O2. We could decrease its concentration. We could remove water. Or we could increase one or both of the products. All of these will have the same effect by shifting the equilibrium to the left. And that will produce more reactant. Now, looking specifically at these 2, we can think about this in terms of pH. If we wanted to lower the H3O+, what we would do is raise the pH. And in this case, if we wanted to raise the H3O+, we would lower the pH. So remember that these 2 are obligately tied together. The definition of pH is the concentration of H3O+, the negative log of that concentration. So we change this concentration by adjusting the pH. Okay, number 3 says, write out the carbonate buffer equilibrium equation we covered that describes how CO2 is related to pH. So this begins with CO2 and water. These 2 will react to form carbonic acid, H2CO3 plus H2O, which will then react to form the bicarbonate ion and H3O+. Okay. Here and here represent the buffer system. This is the acid, and this is the conjugate base. I'm going to abbreviate conjugate. This is 1 less hydrogen than this one. And then the H3O+ over here, remember, is related to pH. So this says, using the equation above, completely describe what happens when someone hyperventilates. Now we need to know something about hyperventilation first. When someone hyperventilates, they are effectively removing CO2 from the bloodstream by breathing really fast. So hyperventilation means that the concentration of CO2 in the blood is going down. So the cause of the disruption is CO2 concentration goes down. The effects of this are the following. The equilibrium will shift to the left. And that will cause H2CO3 concentration to go down. We'll leave water alone, because as I said, water is going to be not going to really be affected here because it's in such a high concentration to begin with. Its effects of the change in equilibrium are negligible. So H2CO3 concentration will go down because there's a shift in equilibrium to the left. HCO3 minus will go down, and H3O plus concentration will go down. This one is the key for understanding how the pH changes. Hyperventilation is going to remove CO2 from the blood, which is going to effectively increase the pH by lowering the concentration of H3O plus. Now the compensation here that happens is that CO2 eventually will sort of be restored to normal, so its concentration will actually go up as a result of the effects here. This says do the same for someone who holds their breath. So the opposite of hyperventilating would be holding the breath. The effect here would be that CO2 concentration goes up. And as a result of that, so that would be the cause. CO2 concentration goes up. The effects of this are that the equilibrium shifts to the right. And that's going to cause an increase in H2CO3. That's going to cause an increase in bicarbonate. And that's going to cause an increase in H3O plus. Okay, and finally the CO2 concentration will go down as a result of the effects, as a result of how the reaction compensates for the disruption. This one here is going to cause a decrease in pH. Okay, H3O plus goes down. That's not a C there, that's a bracket. H3O plus goes up. That's going to cause a decrease in pH. All right, I hope that was helpful.